Section 3.3 is polynomial and synthetic division. We are going to use long division. If y'all remember back in 4th grade or so, you did long division with numbers. We're going to do long division with polynomials. Okay. We're also going to use synthetic division. Synthetic division only works when you're dividing by a linear term, though. Long division, I can use all the time. Synthetic division, I can only be dividing by a line. And then we're going to look at something called the remainder theorem. Just an easy way of solving an equation for a particular value. So here's a graph of 6x cubed minus 19x squared plus 16x minus 4. And you'll see that the 0 of f occurs at 2. We have a 0 right here at 2, and I have a couple more zeros over here. Because x equals 2 is a 0, I can use that factor to find the other zeros. Okay, I can use that factor to simplify this polynomial. I think I forgot to go through and delete some of the stuff on here. So remember that, and this is important on the homework. I was looking at it with Molly earlier. This 0 is at 2. The x value of 0 came from the point x, from the factor x minus 2. Because if you set x minus 2 equal to 0, that would give you x equals 2, right? So this factor is x minus 2. So I'm going to use long division. I'm going to divide this polynomial by x minus 2. And it's probably already worked out. Maybe I did cover it up. Okay. So here's how this looks. I'm going to take x minus 2 into 6x cubed minus 19x squared plus 16x minus 4. That's what I'm about to do. Okay. Here's how it works. What you want to do is look at the leading term and look at the leading term. What can I multiply x by to get 6x cubed? Or look at it the other way. What is 6x cubed divided by x? 6x squared. Okay, so I'm going to write 6x squared right here. Okay, y'all good with that? So 6x squared times x is 6x cubed, correct? I will now take 6x squared and multiply it by this whole binomial. What is 6x squared times x? 6x cubed. What is 6x squared times negative 2? Negative 12x squared. Y'all good with that? Next step. I drew a line. I'm going to change my signs. I will now combine. You like the rhyming there? Draw your line, change your signs, now combine. What happens if I combine 6x cubed with a negative 6x cubed? It's gone. What happens when I combine a negative 19x squared with a positive 12x squared? Do I have anything to combine with the 16x? Bring it on down. Do I have anything to combine with the negative 4? Bring it on down. Okay, so far? I'm now looking at my leading term. My leading term is now negative 7x squared. What is negative 7x squared divided by x? Negative 7x. I will now multiply negative 7x by x minus 2. Negative 7x times x. Negative 7x squared. Negative 7x times negative 2. Positive 14x. Next step. Draw your line. Change your signs. And combine. Negative 7x squared, positive 7x squared. Gone. 16x plus negative 14x. 2x. How about that negative 4? Bring it on down. Look at the leading term. What is 2x divided by x? I'll put a 2 up here. I will now multiply that 2 by x minus 2. 2 times x, 2x. 2 times -2, -4. Draw your line. Change your signs. Now combine. What do we get? Which we better get 0, because we knew that x minus 2 was a factor. We know that x minus 2 is a factor because we know that x equals 2 is a 0, which means I can rewrite 6x cubed minus 19x squared plus 16x minus 4 as x minus 2 times 6x squared minus 7x plus 2. And why do we do this? Do y'all know how to solve quadratics? We can factor, we can complete the square, we can use the quadratic formula. I have all kinds of tools to solve a quadratic. I don't have tools to solve a cubic. Okay, or higher. Yeah. Okay. Questions on that? This is long division. Okay. That's just the name of the process. So here's what we just did. They're kind of walking through what we just did. Okay, and they got the same answer. Next slide. This is what I just told you. 6x cubed minus 19x squared plus 16x minus 4 is the same thing as x minus 2 times 6x squared minus 7x plus 2. And by factoring that, if we factor this part here, it gives us 2x minus 1 times 3x minus 2. I'm not going to go through the process of factoring that. I think we spent enough time on factoring. Okay. Yes. Yeah, you have to find the zeros. Can you tell me what the zeros are? What's this one? Positive 2, 1/2, and 2/3, right? You set each one of those equal to 0 and solve for x. Okay, and y'all should be able to do those in your head like this by now. In example 1, x minus 2 is a factor. It was a factor. When we finished, what was our remainder? Did we have a remainder? We ended up with a 0, right? Well, what if we divide and we get a remainder? Okay. So if I take x squared plus 3x plus 5 and divide it by x plus 1, I get x plus 2 with a remainder of 3. All right, let's back up a little bit. Do y'all remember doing problems that might have looked something like 7 divided by 3? Let's kind of talk through this. 3 goes into 7 2 times. 2 times 3 is 6. Draw the line, change the sign, and combine. It's the same thing we did back then, right? We got a 1. You might have, some people have told me that their teachers never did this. We would say, well, it's 2 with a remainder of 1. Y'all remember that? Y'all remember that? Okay. And then later on, the teacher goes, well, let's just put a 0, a period, a dot here and add some zeros and just keep on going. Y'all remember that? Okay. Do y'all remember the version where the teacher said, well, let's just take that remainder and put it over what you were dividing by? You don't remember that one? Okay. That's the same thing. If I put a dot here and kept on going, I would get 3, 3, 3, 3, 3, 3, 3, 3, 3, which is 1/3. So this number, how would you read this number? 2 and 1/3. Agreed? 2 and 1/3. Would you agree that 2 and 1/3 is the same thing as 2 plus 1/3? Y'all good with that? Are y'all okay with writing this as 1/3? Now, okay. Are you okay with writing this as plus 1/3? Folks, that's what we're going to do here. We're going to take this x plus 2. We're going to write plus 3 over, because that was my remainder. What am I dividing by? That's that simple. So that's going to be the actual answer to this one. So x squared plus 3x plus 5 divided by x plus 1 is equal to x plus 2 plus 3 over x plus 1. Okay? Questions on that? Molly, you got a blank look on your face. How are we doing? Okay. And here it is. Which means I could rewrite x cubed plus 3x plus 5 as x plus 1 times x plus 2. Oh yeah, plus 3. Okay. So there's division. Take your remainder, put it over whichever you're dividing by. Here is the division algorithm. If I'm taking a function, that is my dividend. That's what I'm dividing, right? The dividend goes inside the box, right? Okay. If I divide that, I get d of x, which is my divisor. That's what I'm dividing by, times q of x. That's what I wrote at the top. That was my answer. That was the quotient, plus the remainder. I like examples better than the formula myself. You probably do as well. Yes? Okay. Moving on. Okay. We could also rewrite that as if you divided all three pieces by d of x, which was our dividend, f of x divided by d of x is equal to the quotient plus the remainder over the dividend. That's what our answer looked like. Again, remember proper and improper fractions? 6/5 is proper or improper? Improper. Why is it improper? Yeah, because 5 goes into 6, right? Not evenly, but 5 goes into 6, right? The same is true with functions. If the numerator is a higher degree than the denominator, then it's improper. Okay. If the degree of the top is a lower degree, then it is proper. Before you apply division algorithm, follow these steps. Number 1, write the dividend and divisor in descending powers of the variables. Number 2, insert placeholders with 0 coefficients for missing powers. Guys, that's really totally optional. It's a good practice. For instance, if I was taking 6x to the 5th minus 4x squared plus 2, and I wanted to divide that by x plus 7. I'm writing out what number 2 is actually saying. It's a good practice, and it's going to help you keep everything in line. If you were to write that as 6x to the 5th plus how many x to the 4th do I have? Where are they? I don't have any. So does this mean I don't have any? Is that okay? Do I have any x cubes? Do I have any x squares? Do I have any x's? Do I have any constants? So if you were actually dividing this polynomial, this is how you'd want to write it out. Okay, and those zeros are going to be placeholders. If you're paying attention to what you're doing, they're not 100% necessary. I can do it without them. I don't recommend it. The next method we're going to talk about, you must put the zeros in place. Okay, we're going to talk about, I'm not going to work this problem right now. That takes too long. Moving on. Synthetic division. This is a little shortcut for long division. However, like I said, you must be dividing by x minus k. You must be dividing by a line. And it's best practice when your coefficient is a 1. So if I was dividing by a line that was like 3x minus 7, personally, can I use synthetic division? Yes. It's ugly. If I was dividing by 3x minus 7, personally, I'm going to use long division. Okay? I'm only going to use synthetic division if I'm dividing by x minus k. Okay? Here's a little pattern of what's going to happen. Makes a lot of sense. Not really. We're going to move on. So remember that if I give you a 0, know that x plus k and x minus negative k are the same thing. Okay, synthetic division. Here's an example. Use synthetic division. I'm going to divide x to the 4th minus 10x squared minus 2x plus 4 divided by x plus 3. Step number 1, take what you're dividing by. Set it equal to 0. Get x by itself. What's x? Negative 3. You're going to write, I'm going to erase this. I don't like how they do it. Okay. I'm going to put that negative 3 in a box. Okay. I'm now going to look at what I am dividing. I'm dividing x to the 4th minus 10x squared minus 2x plus 4. In order from highest degree to the constant, what are the coefficients? My highest term is x to the 4th. What is the coefficient? 1. Counting down from x to the 4th. And normally I'm not going to write this part down, but I'm just kind of showing you what's going on here. So this is the coefficient for x to the 4th. Let's count down. The next term would be x cubed. How many x cubes do I have? Okay, none. Okay, how many x squares do I have? Negative 10. How many x to the 1st do I have? Negative 2. And how many x to the 0s do I have? 4. Again, I'm not going to write this down when we're going forward. Know that you start with the highest degree, take that coefficient and count down, and you must represent every single one of them. Okay? Questions on this so far? I'm going to leave some space right here because I'm going to write in that spot. I'm going to draw a line down here. I've now set this up for synthetic division. I'm now going to perform synthetic division. First step, you will always, whatever that first number is, bring it straight down. From here on out, I'm going to do 2 things. Multiply, combine. That's all I'm going to do. So multiply. Negative 3 times 1 goes right here. Combine those. Multiply. Negative 3 times negative 3. 9 goes right here. Combine. Negative 1. Multiply. 3. Combine. Combine. Multiply. Combine. Okay. That last number, I'm going to set it apart. That last number is my remainder. Okay. Now, I started with a 4th degree polynomial. If I take a 4th degree polynomial and divide it by x, what's it going to become? It's going to become a 3rd degree polynomial. Everything is going to drop by 1 degree. So this was x to the 4th. This is now x cubed. This was x cubed. This is now x squared. This was x squared. This is now x to the 1st. This was x to the 1st. This is now my constant. Oh yeah. Plus I have 1 left over, and I was dividing by what? What was I dividing by? X plus 3. And that's the answer. Okay. I'm going to go back a couple slides. Yes. Okay. This one had a remainder of 0, correct? I'm going to do this one synthetic division. What am I dividing by? I'm dividing by x minus 2, which means x equals 2 goes in my box. My coefficients are 6, negative 19, 16, negative 4. Did I need any zeros? 3, 2, 1, 0. I don't need any zeros, do I? Draw my line. Bring the 6 down. 2 times 6, 12. Combine. Kind of look familiar? 2 times negative 7. Negative 14. Combine. 2. That look familiar? Multiply. Combine. I didn't have a remainder, did I? This was a cubic. I divided it. This becomes linear. My answer here, 6x squared minus 7x plus 2. Do you see how synthetic division is a shortcut to long division? Okay. I didn't have to change my signs in synthetic division. How come? Y'all see it? We changed the sign right here once, right? Okay. Yeah, we took care of that a long time ago. Okay. And that's the problem we just did. If y'all want to look at the way they did it with their boxes and everything, that's cool. I just do it the way I was taught. But you're welcome to do it either way. Okay, the remainder and factor theorems. The remainder in synthetic division is what you would get if you plugged that x value into the function. Now, using a calculator is not a big deal, right? What I'm saying is, you see this function here that we did a while ago? If I took an x value of -3 and plugged it into that, go ahead and do it. Here's the function, plug -3 into this. The answer is already on the screen, but I want you to plug -3 into this real quick. This is where you pick up the calculator and you change the x's to -3 and you actually do this. You got 1, which is the remainder. Okay. So if I didn't have a calculator, doing the synthetic division does not take me any time. And plugging in -3 to the 4th power, I don't want to do that. I mean, it's easy, but does that make sense? So that's what the remainder theorem is telling us. We'll go back to that. The remainder is what you would get if you plugged that value into the function. So what if the remainder was 0? What does that tell you? If the remainder is 0, it's a factor, right? If the remainder is 0, that tells you that that value is a factor, or it is a solution. Okay. Using the remainder theorem to evaluate when x equals -2. So when x is -2, I can take this problem. My coefficients are 3, 8, 1. Okay, we're good. 3, 8, 5, and -7. I don't have to put any zeros in there. Bring the 3 down. -2 times 3 is -6. There's the 2. -2 times 2 is -4. Combined gives me 1. -2 times 1 is -2. Combined gives me -9. Set that apart. That's my remainder. F of -2 equals -9. Y'all okay today? Okay. And if you wanted to go through and plug it in to make sure, you could do so. And you still get -9. We talked about this already. Another important theorem is the factor theorem, which is stated. The factor theorem tells us that when the remainder is 0, it's a factor. That's what the factor theorem tells us. Factor theorem says if the remainder is 0, then you now have a factor of the polynomial. It says to show that x minus 2 and x plus 3 are factors of this quartic. This is a 4th degree polynomial. It says to show that x minus 2 and x plus 3 are factors. Well, what you do is use synthetic division. If x minus 2 is a factor, then if I use 2 into the function, I will get a remainder of 0. Y'all good with that? Now, I don't know exactly which way this thing's going to go. So how would I go about checking to see if x plus 3 is a factor? Do it all over again using synthetic division. How would I find out if x plus 3 is a factor? The -3, right? Because this is x plus 3 equals 0, meaning x equals -3. So I'm going to put -3 in my box. What are my coefficients? Don't use the same ones. Okay. Obviously, if x minus 2 and x plus 3 are factors, I could go back to the beginning, but why don't I just use my new numbers? Right? Because if x plus 3 is a factor of the whole polynomial, then x plus 3 is probably going to be a factor of this depressed polynomial. And that's actually what it is called. I took a 4th degree polynomial. This is now a 3rd degree polynomial. I know it's a sad thing, but it's called a depressed polynomial. So I'm going to use these numbers: 2, 11, 18, and 9. Draw my line, bring the 2 down. Combine and multiply. -3 times 2, -6. Combine, times -3. Combine, times -3. Combine. Is it a factor? I verified it. Okay. Here's what happened. I had a 4th degree polynomial. This is a 3rd degree polynomial. What's this going to be? Fourth degree, 3rd degree, which is a quadratic, right? So I'm down to 2x squared plus 5x plus 3, which means I could factor it, quadratic formula that. I could complete the square. I could find the other 2 zeros right now. They gave me 2, took a 4th degree polynomial down to a quadratic. Now I can use all the tools that we have to solve this. Okay. Right. Okay, they plugged it into the depressed polynomial, and they got 2x cubed plus 5x plus 3. We could factor that into 2x plus 3x plus 1, which now allows us to have all 4 factors of our quadratic. Moving on. Okay. And that was, in fact, the end of 3.3. Stop it there.